class. We have one more topic left about 2.2. And to understand the topic, I'm going to start from the famous fundamental counting principle. I want you to connect this principle with one of the three examples I'm going to give you. The first example, let's consider this task. Let's say your task here is to drive from A to C, passing through B. Your task here is to drive from A to C, passing through B. And we know from A to B, we have two different routes. From B to C, we have three different routes. You can go here, go here, go here. Question here is, to complete the task, drive from A to C, passing through B, how many different ways do you have? How many different routes do you have? Go from A to C, passing through B. Please do not tell me 5. Think about it. From A to B, we have 2 different routes. From B to C, we have 3 different routes. Then how many different routes we can go from A to C, passing through B? Let's see your answer. Too many. We don't really have. Oh yeah, Chloe Jackson. Awesome, thank you. We have 6. All right, we have 6. From A to B, we can take the northbound. If we take the northbound, we can go this way. 1, 2, 3, right? And then, or from A to B, we can take the southbound. 4, 5, 6. We have 6 routes. We don't have more than 6 routes. And we can get the number of ways to get the task done by using the fundamental counting principle. The fundamental counting principle says, if your task has 2 parts, and the first part, you have 2 different ways to get it done. The second part, you have 3 different ways to get it done. Then the multiplication of the 2 numbers would give you the number of ways you can finish the task, which is 6. All right? What is fundamental counting principle? I want you to connect the principle with this example. If your task has 2 parts or 2 steps, the number of ways to get this task done equals the number of ways to get the first part done times the number of ways to get the second part done. So knowing you are doing multiplication, you are not doing addition or any other operations, you are multiplying. I'm present. Emma, do you mind to email me later? I don't really want to go through the thing again. If you email me next time when I do my student hour, I can fix your attendance. All right, thank you. We actually have more than just Emma. Guys, if you join a meeting after I finish the roll calling, please remember to email me and let me know you are present. Then I can fix your attendance. I just don't want to do it now in the middle of the class. Thank you. Very good. Let's consider the second example. The second example, ladies, let's say tonight you have a party, all right? And your task here is to dress yourself up. Let's say you have tops, bottoms, and heels to choose from. Let's say you have 2 different tops, 3 different bottoms, and you have 5 pairs of heels. Okay, let's say you have a lot of heels, very pretty. then how many different ways you can dress yourself up? We do not consider makeup or jewelry. Your task is only to pick a top from the 2 tops you have, and then a bottom from the 3 bottoms you have, and pick 1 pair of heels from the 5 pairs you have. How many different ways you can dress yourself for the party? What do you think? This task has 3 parts, right? Or you can say 3 steps. Excuse me. The first part, you have 2 ways to get it done, right? The second part, you have 3 different ways. And the third part, you have 5 different options. So how many different ways you have to complete the whole task? Yeah, what are we talking about? We are talking about the fundamental counting principle. How do you get a 10? So I can show you we have more than 10, a lot more than 10, okay? So we can make a tree. If top 1, so when we choose top, we can do top 1, top 2, right? Suppose you choose top 1 and you have 3 skirts, skirt 1, skirt 2, skirt 3. And this one also, you can choose skirt 1 or skirt 2, skirt 3, right? And you also have 5 different pair of shoes. If you choose the first skirt, and you have 1, 2, 3, 4, 5 different pairs of shoes. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Look how many do you have? You have 30. If you want me to show you, this is a draft of the tree graph that can show you we have more than 10, right? So this is the top. You can choose the first top, or you can choose the second top. Suppose you choose the first top, then you can choose the first bottom, or the second bottom, or the third bottom, right? Same ways, if you choose the top 1, top 2, you also could choose skirt 1 or skirt 2 or skirt 3, right? And you already have 6 right now before you even pick your heels. And for each of those 6 possibilities, you have 5 pairs of shoes to choose from. So you can wear your first pair or second pair, right? And so each case you have 5 pairs of shoes. 5 times 6, that give you 30, guys. Again, fundamental counting principle. Do not do addition, they do multiplication. I hope you hear me right now. Fundamental counting principle, do multiplication. Let me repeat the process. So we can use fundamental counting principle to find the number of ways you get a task done. Suppose the task has 3 parts, and the number of ways to get a task done equals the multiplication of the ways to get each part done. In this case, we have 3 parts. And the first part, choosing a top, we have 2 options. The second part, we have 3 options. The third part, we have 5 options, which is in the multiply them together, okay? I hope you remember this example, and knowing you're multiplying, you have 30 different ways to dress yourself. That means if you go to the party every day, you have different outfit. You have different looks. You can go every day for a month, you don't repeat your looks. All right, please remember is multiplication, fundamental counting principle. All right, gentlemen, so let's say earlier the second example is for ladies. The next one is for gentlemen. Your task here is to order a meal from a restaurant. Let's say your meal includes appetizers, entree, I don't know the spell, I'll just write this, ANTR, and the dessert, Let's say the restaurant has 3 different appetizers, 4 different entrees, 2 different desserts. Then how many different ways you can order your meal? How many different ways you can order your meal? You order appetizer first. You can choose any one from the 3. And then you order your entree, any one from the 4. And then you order a dessert, any one from the 2, maybe chocolate cake and cheesecake, right? Then how many different ways you have to order the meal? Awesome, perfect. Very good, 24, perfect. You multiply again, you multiply together, right? You have 24 different ways to order your meal. I want you again connect one of the 3 examples. Yeah, which example you feel more impressive compared with the other 2? Which example you like the best? Connect that example with the fundamental accounting principle. Whenever you need to use fundamental accounting principle, or you encounter the 3 words, you need to remember that example. And you need to know, what does fundamental accounting principle do? Fundamental accounting principle helps you to find the number of ways to get a task done. Okay, suppose the task has multiple parts. You just need to multiply the number of ways to get each part done and multiply those numbers together. All right. I hope this is clear, guys. What is the fundamental accounting principle? I hope this is clear. All right, thank you. Thank you for your response. Thank you, Chloe. All right, now we are going to use the fundamental accounting principle to complete this task. What is the task? Let's say A is a set. Yeah, we are talking about set theory, right? Let's say A is a set. A has 3 elements, A, B, C. Okay? And our task here is create a subset for A. How about do this? Create a B, create a set B such that B is a subset of A. You remember this notation, right? Set B is a subset of set A. Let's recall the definition. What is subset? B is a subset of A means all the members, all the elements in B are also in A. Okay? B is a subset of set A. If all the elements in B are also elements in A, then B is a subset of A. Here, our task is to create a subset for A. And we want to know how many different subsets we can create for A, or A has. All right, so let's focus on this task. Create a subset for A. We use B to represent the subset. In order to be a subset of A, the elements in B have to be elements in A, right? Yeah, the elements in B must, if there are any elements in B, the elements must be in A as well. So I'm going to come up with a process. Okay, I'm going to come up with a process. By going through the process, we would be able to create a subset for A. The process is, we are going to look at every single element in set A. Okay, so since A has 3 elements, my process has 3 steps. The first step, we look at the first element in set A, which is A, little a. And how many different options do we have here to, when we create set B, we consider, are we gonna include or exclude? We may include A in B. We also could exclude A in B, right? As a subset, B doesn't have to include all the elements from A. It could, but it could not as well. So here we have two options when we consider element A. And so when we go through the elements in A, the first element, we have two options, either include or exclude. Now we go to the second step. Look at the element B. For element B, we also have two options, either include or exclude, right? Yeah, my subset B could include B, could also maybe not include B. And step 3, the last element is C. For C, we also have two different options, either include C or exclude C, right? After I go through the 3 steps, I should have my subset B. Then you tell me how many different ways I can get this task done. How many different ways I can create subset B for A. My process here has 3 steps. The first step, include or exclude element A. So I have 2 options. Second step, include or exclude B, also 2 options. Third step, include or exclude C, also 2 options. So together, awesome, you guys are great. Fundamental counting principle, right? You guys are great. We have 8 different, 2 times 2 times 2. We have 8 different ways to create the subset B for set A. I can give you the 8 subsets, okay? Yeah, we have 8 different ways to create a subset B for A, means A has 8 different subsets. The 8 different subsets are, it could, when I consider A, B, C, I could include them all, right? This is a subset. Or when I consider the 3 steps, I may maybe only include 1 element and exclude the other 2 elements. In that case, we have those 3 subsets. I also can include 2 of the 3 elements, exclude 1 of the 3. So maybe the 2 elements I include are AB or AC or BC. Or when I, consider the 3 steps, I can exclude all the 3 elements. Then I have the empty set. Did we talk about empty set? Yeah, the empty set. So look at the guys, how many different subsets set A has? 1, 2, 3, 4, 5, 6, 7, 8. Those are all the 8 subsets for A. Do you see it, guys? Do you agree? Okay, very good. Thank you. And I have a question here. How many different proper subsets? Let me repeat my question. A here is a set containing 3 elements. We already know the set A has 8 different subsets. My question here is, how many different proper subsets A has? A has, A has 8 different subsets. And how many proper subsets? What's the definition for proper subsets, guys? Proper means the subset is not equal to the original set. All right, you can maybe understand this. This is a proper. Even both statements are true. Do you agree? Both statements are true, right? You can see this is a proper. 2 is not equal to 3, so this bar does not hold, so it's proper. So when it comes to set theory, A is, I can write a definition for here in case you forget. B is a proper subset of A if all the elements in B are in A. On top of that, and there is at least one element in A that is not in B. This is the formal definition for proper subset. In other words, proper subset means this equal does not hold. Proper subset means the equal does not hold. That means subset B has a smaller size. Subset B has a smaller size than set A. Yeah, look at the definition and consider. I am here. Okay, Charlie, would you email me for your attendance? I'm not going to fix right now. Guys, in the future, if you miss the roll call, please email me after. I'm gonna fix it after. I don't want to go back and forth to stop in the middle of teaching and do that. I appreciate you guys coming. Remember to email me, okay? Okay, so set A has 3 elements. It has 8 different subsets. Among the 8 subsets, how many of them are proper subset? How many of them are proper subset? Guys. Is this proper, ABC? This one is not proper, right? But all other seven subsets are proper? You're right, Jackson. Do you see it, everybody? I wrote those 8 subsets. Those are 8 subsets for set A. Among the A subsets, only this one itself, this subset is the same with the original set, right? Only this one is not proper. All other 7 are proper, right? Yeah, okay. So the number of proper subset is always 1 less than the number of subsets. This set has 8 different subsets. It has 7 different proper subsets. Okay. I'm trying to derive the formula for finding the number of subsets for a given set, finite set. Let's consider this similar situation. A has A1, A2, A sub n, this many elements. Can you tell me what is the cardinal number of A? If A has a sub 1, a sub 2, and so on, a sub n, that many elements in the set, what's the cardinal number of A? What's the cardinal number of A? This might be a little bit challenging because it's a little bit abstract. Just do not tell me 3 or 6. N, yes, not infinite, is finite. Not 4. The dot here means a lot of between. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on continue until a sub n. What's the value of n? We don't know. Okay? It is a finite number. So the cardinal number of the set is n. N could be any natural number. N could be any natural number. So we're going to apply the process we applied earlier to find the number of subsets for this set. The process would be n steps. The first step, I consider include or exclude a sub 1, right? So 2 options. Second step, I consider include or exclude a sub 2, 2 options. And third step is include or exclude a sub 3, another 2 options. And so on until the last step, I consider include or exclude the last element. So I have 2 options. How many 2's here in this multiplication? Anybody can see how many 2's in this multiplication? These 2 options is to determine include or exclude a sub 1. These 2 options is second step, include or exclude a sub 2, right? And so on. And the last 2 is the 2 options, include or exclude a sub n. Do you see there are n 2's in the multiplication? Let me know. Do you see there are n 2's in the multiplication? Awesome, very good. Feel free to text in the chat. If it's anything not clear, just let me know. Very good. So this multiplication can be written as 2 to the power of n. Okay, when n equals 3 is 2 to the power of 3. When n equals 4 is 2 to the power of 4. When n equals 5, when the set has 5 elements, it is 2 to the power of 5. This is the theorem. I'm going to write a theorem here, right? If which one has, okay, this one. A is a set. If the cardinal number of A is n, then A has 2 to the power of n that many subsets, and 2 to the power of n minus 1 that many proper subsets. This is the formula that you need to remember. Our exam is going to be close book, close note. You need to understand and remember the formula. I never remember anything without understanding. I suffer if I have to memorize something that I don't understand. But if you understand a thing, it's not difficult to memorize. That's the reason in the past, half an hour, I'm talking about the process, right? We start from fundamental counting principle. and then I give you a situation, the set has 3 elements, right? 3 elements. And we figured out if the set has 3 elements, it has 8 different subsets. How do we get the number 8? 2 times 2 times 2. That is 2 to the power of 3. 2 to the power of 3 is 8, right? And then I give you a general case when the set has n element. When the cardinal number of the set is n, then the number of subsets of the set is 2 to the power of n. Minus 1, we have the number of proper subsets. Well, you need to understand and memorize. I recorded the class. If you don't understand, repeat it, all right? So far, so good? 2 to the power of n. That's the number of subsets. N here is the number of elements in the set, the cardinal number of the set. Okay, then let me ask you, if I'm a little confused, but I'm getting there. Oh, thank you. So if the cardinal number of A, okay, how about this? If set A include A, B, C, D, 4 elements, how many subsets does A have? How many different subsets? Yeah, how do you get a 16? That's awesome. Thank you, Charlie. How do you get it? 2 to the power of 4, right? 2 to the power of 4 is 16. 2 to the power of 4 is 16. 2 times 2 times 2 times 2 is 16. Then how many different proper subsets set A has? Proper subset. How many proper subsets? Very good, very good. Awesome. Okay. What if n of A, remember what the notation mean, equals 5. How many different subsets does A have? Okay, what if the cardinal number of A is 5? Then how many different subsets set A has? Very good, thank you. How do you get that? 2 to the power of 6, right? Yeah, 2 to the power of 6. 2 to the power of 6. Try to figure it out. If you don't know how to calculate it, try to figure it out using your calculator. Let me give you a calculator. If I use the TID4 calculator, is the fancy one that we recommend it for this class. Wouldn't it be? Yeah, exactly. It is. Oh, my bad. My bad. I typed it wrong. 2 to the power. Okay. 2 to the power of 5. My bad. 2 to the power of 5. 2 to the power of 5 equals 32. All right. Yeah, we can use we can do 2 to the power of 5. The TID4 calculator, this is just a piece of cake for this type of calculator, 32. Or you can just do 2 times 2 times 2 times 2 times 2. You make sure you have 5 2's here. Fundamental counting principle, and you have 32. Then how many different proper subsets? Proper subsets. How many different proper subsets? Yeah, exactly. Good job, Charlie. That's correct. Very good. Perfect. All right, so that's the last topic we need to cover from section 2.2. it gives us formulas to determine the number of subsets and the number of proper subsets for any given finite set. Perfect. Thank you, Ashley. Are you guys ready for 2.3? Okay, let's do 2.3. I need to see how do I insert a blank. More blanks. Okay. All right. 2.3, we are talking about Venn diagram. And the operations of sets. VENN, Venn, is a mathematician and a logician. If you are interested to know more about him, you can Wikipedia. And here, we don't do that. Just to know, the type of diagram we are going to learn is named after him. What type of diagram? This type of diagram. Venn diagram always have a box. Then this is supposed to be a rectangle. Okay, my drawing isn't the best. It's supposed to be a rectangle, like a box. All right, and the box represents the universal set. And in the box, we can have sets that represented by circles. For example, I can draw a circle and let this circle represent a set A. I can draw another circle and let this circle represent the set B. I can draw more circles if I want. Let's say this one represents set C. And we can study the relationship between those sets in the box. Let me give you the basics about this section, in this section. Firstly, U here is the universal set. Okay? U here, the box here, is a universal set. It contains all the elements in discussion. It's important because the universal set gives us the scope of your study. If you are about to study all the full-time students at TCC, then all the full-time students would be the elements in a box. If a student is not full-time, is a part-time, then the student not supposed to be in the box. It should be outside the box. So the box here gives the universal set. It tells us all the elements under consideration. All right, gives us the scope of your study. And the next concept, I want to use a different color. So here, this. And next one, A prime. This is called an A prime, okay? A prime here is a complement of A. A prime here is also a set. Is the set of all elements that are in U but not in A. A prime here, you can read it as not A. A prime here means not A. Okay, A prime here means not A. So let me give some elements in the diagram, the Venn diagram. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so anybody can help me to find a universal set. Let's use the raster method to find a universal set. Do you agree? The universal set contains all the elements in a box, and they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is not difficult, right? Okay, so how do we find A prime? What does A prime mean? A prime means not A. This set contains all the elements in a box, but not in set A. Let me color this yellow region. This yellow set is A. Okay, the yellow set is A. The yellow set A contains 3 elements. 1, 2, 3. I believe everybody sees that, right? And how do we find A prime? Let me show you the technique we use to find A prime. You write a universal set on your scratch paper, and also write a set A on your scratch paper. And then you are going to cross out the elements in A, okay? 1 is in A, cross out. 2 is in A, cross out. 3 is in A, cross out. You cross out all the elements in A. The leftover elements, other elements in U, in the universal set, would be in A prime. So A prime includes 4, 5, 6, 7, 8, 9, 10. Do you see it, guys? Do you see it? Very straightforward, right? I believe the actual challenging part is the notation. Just make some effort to understand and memorize those notation. I think you'll be fine. Pretty intuitive content. Awesome, very good. And next, notation. A union B. A union B. In between A and B, we have a capital, there's like a symbol look like a capital letter U, right? You can remember that, okay, it's capital letter U, union. And what does A union B means? A union B means A or B, A or B. And A union B, A or B is the set of elements in A. Let me start a new line. In A or B, okay? This notation, A union B, this notation represent a set. In the set, we have all the elements in set A or set B, okay? All the elements in A or B, all the elements in A or B. A union B is the set of elements in A or B, okay? And I'm going to spend a little time to talk about OR here. In logic, we have 2 types of OR. We have 2 types of OR. The first type of OR, we have 2 types of OR. One is exclusive OR. The other is inclusive OR. Let me give you an example. Let's say you go to a restaurant for lunch, and the waiter tells you, if you order a specialty lunch today, you will have a complimentary soup, cup of soup, or a complimentary salad. Let me repeat. You go to a restaurant, the waiter tells you, if you order the specialty lunch for today, you get a soup for free or a salad for free. Do you think you can get both for free? What do you think about the waiter's mean? Do you think you will have both the soup and the salad for free? No, yeah, you're right. You will not. When the waiter tells you a salad for free or a soup for free, the or here is exclusive or. If you get a complimentary soup, you won't have salad for free. If you get a complimentary salad, you will not have soup for free, right? One or the other, not both. So exclusive or means one or the other, not both. Okay? Huh? What happened here? Never play this part. Okay. All right. So that is an example for exclusive or. And what is inclusive or? Let me give you an example. Let's say, some theme park have the game. You have a target, right? You have a target. Let's say the target look like this. You might not see something like that, but I'm just made it up. So the guy told a little kid, the kid is going to play the game. What kind of game is? The game is throw the dart. So if the kid can throw the dart and hit A or B, he got a stuffed animal. As a reward. All right. So here, if the kid can hit region A or region B, the kid get a stuffed animal. The kid wins a stuffed animal. So what do you think about OR here? Exclusive or inclusive? If the kid hit here, he got the animal, right? Stuffed animal. If he hit this part, will he still get a stuffed animal? But what if he hit this part in the middle? Will the kid still get a stuffed animal? Do you agree that as long as he hits any of, as long as he hits the shaded region, the kid will get a stuffed animal as a award? Do you agree? And in this case, the or is inclusive or. Yeah, inclusive or. Inclusive or means this part only A, not B. This part only B, not A. And this part A and B, including both. So let me type what is inclusive or. Inclusive or means only A or only B or both. Okay, so this is inclusive or. And in our course, this class, quantitative reasoning, all the or are inclusive or. All the or are inclusive or, right? So now we go back understanding the notation A union B. A union B, the notation represents a set. The elements in a set are all the elements in A or B. In A or B, okay? So let's see, how do we find A union B? Look at the Venn diagram. This yellow one is the yellow set is A. The pink set I can do colors. The pink set is purple, pink. Yeah. So what is A union B? What is A union B? What elements are in the set A union B? Do we have a 1? Do we have 2, 3, 4, 5, 6? Yeah, the online remote class is a little bit weird and not very efficient when I ask questions. It probably take a while for you to respond. Do you agree, guys? A union B? Perfect. Perfect. Thank you. Yeah, 1, 2, 3, 4, 5, 6. Perfect. Awesome. Pretty straightforward, right? For A union B, I mentioned this earlier, is all the elements in this region. All the elements in this region, right? Then it includes 1, 2, 3, 4, 5, 6. And that's it. Very good. Next. The notation here is not a U, it's the upside down. The union notation, flip it, upside down, U. This notation represents a different concept. It means intersection. This notation represents the intersection of set A and set B. It is the set of elements in A and B. In A and B. One word different. A union B, or. A intersect B, A and B. So this set contains all the elements belong to both A and B. In other words, A intersect B include all the common elements of the two sets. And let's go back to the original, let's go back to the example that I gave you in the park. The little kid threw the dart, right? And the owner says, if you hit the region A and B, if you hit the region A and B, you get a what? A robot. Get a robot. All right. So which region do you think the kid should aim at? This time is more challenging, right? Do you agree it's more challenging to get a robot, not a stuffed animal? Yeah, if he throw the dart and the dart hits the region A and B, he got a robot. So do you agree the little kid should aim to this region? That is A and B, right? The overlapping region, the common part of the two sets. This time, if he hit this part, no, that can only get a stuffed animal, right? This part doesn't work either, because that part only belongs to A, not B. He has to hit a region belong to both. Then he can get a robot. Do you see it? Do you agree? And can you tell me, what is the A intersect B? In this case, yeah, we can actually erase this now. Pretty straightforward. I would say very intuitive. Again, probably the only thing that may challenge you is the notation. So in our Venn diagram, A intersect B should be the orange, kind of like an orange color region, right? The common part, perfect, is 3. Awesome. You guys are great. A intersect B can turn one element, which is 3, because set A and set B only have one element in common. Awesome, very good, perfect. One more definition before we look at more examples. One more definition. Set A. Oh, okay. How about this? Two sets are disjoint. Disjoint is also called mutually exclusive. Just different name. It means the same thing. We say two sets are disjoint if their intersection, we just learned what is intersection, right? If their intersection is the empty set. Okay? Yeah, definition for disjoint. Two sets are disjoint. Dis means negation, right? Joint means touch, have something in common. So two sets are disjoint if their intersection is empty. Doesn't that mean two sets are disjoint if they have no common elements? They have no overlapping part in the Venn diagram? And look at here. Are A and C disjoint? And by the way, you can unmute yourself and answer the question faster. What do you think about A and C? C, let me color. Let's say C is the green set. C is the green set. Are A and C disjoint? They are, right? Yes, Ashlyn, they are, because they have no common element. If two sets have no elements in common, they are disjoint. I can type the definition here. If two sets have no elements in common, like they don't share any elements that is the same, they don't have any common elements, then the two sets are disjoint. Right? They do not overlap. Are B and C disjoint? B and C. From the Venn diagram is even more straightforward to understand the concept, right? If the two circles don't touch, do not overlap, then they are disjoint. B and C are also disjoint. But A and B are not, because A and B overlap. They have one element in common. All right, guys? So we learned what is a universal set. The notation for universal set is a capital letter U. That is a handwritten capital letter U. I do a bar on top of the U. All right. What is a complement? A complement is denoted as A prime. You can read this as not A. Not A is a set containing all the elements in a universal set, but not in set A. A union B includes all the elements in A or B, or here is inclusive. A intersect B include all the elements in A and B, right? I have a question here. Do you agree A intersect B is a subset of A union B? Is A intersect B a subset of A union B? Yeah, let's recall. What is subset? What does subset means? Yes, it is. Yeah, correct. It is. We can look at the Venn diagram. The orange region is the intersection, right? And this region, I'm tracing the boundary for the region, is A union B. And obviously the orange region is completely inside of the, A union B. So if we use a Venn diagram to denote subset, this is what we do, okay? If we use Venn diagram and we have these two sets, set A completely fall inside of set B, then A is proper subset of B. Proper subset of B, okay? But is A also a subset of B? This is a Venn diagram. Based on the diagram, we see the set of A fall completely inside set of B. So we agree set A is a proper subset of B. But can we also say A is a subset of B? Can we also say A is a subset of B? Can we say both? You have something similar in MyLab Math. They would ask you, do you put this notation or this notation only, or you can do both or neither? In this case, is both, right? A is a proper subset of B, and A is also a subset of B. It's just like A is strictly less than 3, but A is no more than 3 is true as well. Right? I hope it's clear. Please let me know. Yes, yes, both. All right, very good. Perfect. Let's look at a problem in a guided note. Let me get my note very quickly, all right? And let me show you how to download the guided note. So let's go to our Blackboard shell, course shell. And the last one is the last two items, two sections. Watch the videos, study the notes. In studying the notes, I have two sets of notes. The guided notes is something we follow in the class. And today we are covering 2.3, right? So you can click that and download the guided note. Let's look at a question on the guided note about the operations of the sets. Yeah, I'm talking about this one. Let U, the universal set, be a set containing A, B, C, D, E, F, G, H. Set A contains A, G, H. Set B contains B, G, H. Set C contains B, C, D, E, F. So we have those information given. We need to find the following sets and write them in a raster method. Okay, let's start from the first one. Number 1, number 2, number 3, number 4. I'm labeling them like this. Hold on. Here. Computer about to die. Oh, thank you for letting me know, Emma. You want to connect your cable and join us again. I'm recording the class. If you have to miss it, then just rewatch it. Watch the recording later. Okay. All right. So the first one, B intersect C. You know, actually, when you see B intersect C, you can just read it as B and C. B and C. Yeah, what is B and C? What elements in B and C? B is here. C is here. B and C. Yeah, knowing where to and, not or. Where to intersection, not union. So intersection. Are we looking for the common elements of B and C? Set B and set C. Do they have any elements in common? Perfect, just one element in common. So you also need to remember to put the braces. Yeah, element B is in common, is the common elements of the two sets, and you use a braces to frame B, and this means a set. Okay, you do not just do B, you have to frame B with the set notation. Very good. That is number one. Number two, we are looking for B prime union C. One important thing that we need to know is to see the structure of the notation. When the notation becomes like too complicated. And this one is not that bad. B prime union C. The biggest structure is a union. This is a union of two sets. Is the green part and the yellow part. All right. The yellow set is given, set C, but the green is not given. We have to figure it out. So let's figure out what is B prime first. And we have this union, a universal set. It has A, B, C, D, E, F, G, H. It does not spend you too much time to write a universal set on your scratch paper. It does not take too much time to write set B on your scratch paper either. So set B has B, G, H. To find the B prime, this is what I do to find the B prime. I cross out the elements in U but not in B. Okay, B has letter B, no, crossed out. Set B has letter G, crossed out. Set B has letter H, crossed out. So we cross out all the elements in B, then the leftover would be in B prime. B prime would have A, yeah, the leftover, I can color them in yellow. Oh no, different color. I can do this. A is here, B, C is here, D, E, F, right? So B prime is A, C, D, E, F. Do you agree, guys? Do you agree, guys? It's very easy, right? The complement, yeah. So I know you're smart. Some of the students are trying to use brain power to figure out what is B prime. I would say sometimes your brain tricks you. Sometimes if you're trying to do everything in your head, you might make a mistake. So the most reliable way, the way I recommend is you write it down. Write it down like what I did just now. Write U, write B, and B prime. Cross out all the elements in B from U, the leftover elements would be in B prime. You will never make a mistake if you follow that. Okay? All right, so now we have the set green B prime. We also have a set C in yellow. Okay, now look at the green set and the yellow set. We are getting the union of them. Union. Union is different from intersection, right? Union here means or. So it's bigger. It's supposed to be bigger. So it should include all the elements in the green or in the yellow, right? Okay. Do we include A? We include A because A is in green. Even it's not in yellow, it's fine because it's or, right? We also include B because B is in yellow, not green, but it's fine. And we also include C is in both, D is in both, E is in both, F is in both. And that's B prime union C. Do you agree, guys? Am I too fast? Just let me know. You just need to write everything down, understand the concept, and you should be fine. So far, so good? Okay. Yeah. Okay, no questions. So I'm gonna continue. Number three. Number three, how do we understand this structure? Okay, I'm gonna decolor them, okay? I'm gonna decolor them. Later, I'm gonna use a different set of colors. So number three, we are looking for A union B inside a parentheses and then prime. Interesting, right? So the structure is we are looking for, we need to find A union B first and then find the complement for A union B. So we are looking for the complement of A union B. So we'd better find the A union B first. Union means or, right? And we have an A here, B here, and then we are looking for the union. So we include A, B, G, H. A, B, G, H. That's A union B. And let's see, how do we find the complement of A union B? Now, do not try to do that in your head. Yeah, maybe this case, the chance to make a mistake is not very high because it's very simple. In other cases, if you have the bad habit to try to figure out everything in your head, you very likely make a mistake. So spend a little bit of time to write down a universal set. A, B, C, D, E, F, G, H, right? And then I'm going to cross out the elements in A union B. Cross A out. A union B has A, B, G, H, right? Cross A out, cross B out, cross G out, cross out H. And then we have C, D, E, F left. And those elements are in the complement of A union B. So So we have C, D, E, F. Questions? Do you have questions? Yeah, I would really recommend to do the cross, method. Oh, perfect. Thank you, Jackson. The last one. Oh, the last one has a pretty complicated structure, right? Yeah, let's figure it out. The last one, the structure is purple intersect blue. Use a different set of color. This is intersection. This notation represents an intersection of the set of purple and the set of blue. Set of blue is given. We know the blue. The blue is B, right? But set of purple is quite complicated. Let's take time to understand what is the purple. So firstly, we need to understand A prime intersect C has A prime in it. So we want to figure out what is A prime. When you encounter a question like this, do not rush. Never try to figure it out in your head. You want to break it down, decompose the structure, and do one piece at a time. Let's find A prime first. To find A prime, I would again spend time to write down the universal set. A, B, C, D, E, F, G, H. It doesn't spend me a lot of time, maybe just a few seconds, right? And also write down my set A. It is given. Set A contains AGH. AGH. Okay? So in the universal set, I cross out A, cross out G, cross out H. I cross out the three elements in A. Then I have my A prime. My A prime contains B, C, D, E, F. B, C, D, E, F. And that is my A prime, right? That is my A prime. Let me bubble my A prime. And also bubble set C. Bubble set C. And you tell me, what is A prime intersect C? What is A prime intersect C? The two sets that I bubbled. Actually, do they happen to be the same? Is it coincident, by the way? They don't have to. C, D, E, F. I got a C, D, E, F. I have B as well. I have B as well. A prime has a B, C, D, E, F. C also B, C, D, E, F. So the intersection of A prime and C is B, C, D, E, F. Be careful. Even means one element would be different, all right? So that is the purple. That is the purple set. Do you agree so far so good? Oh, do you actually have the final answer? So the blue is a BGH. The blue is a BGH. Oh no, your answer probably not right. BGH. Okay, I'm gonna write the blue here. B. BGH. That's the blue. Number 4, we are looking for purple intersect blue. So we are looking for the intersection. So purple intersect blue. Yeah, purple and blue. You see the two sets. We are taking the intersection. The intersection, they only have one element in common, right? Is B. Do you see it? Do you see that? Yeah, just one element, right? So your answer only is a set with one element B. And that's how do we excuse me. And that's how do we break it down. Do one thing at a time. Do one thing at a time. Okay, we run out of time. Watch the video if you need a more reinforce of the content. Rewatch the video is always the good method. Thank you guys. Again, if you miss the roll call, please remember to email me. Otherwise, you miss the attendance. Your attendance score will be compromised. Thank you guys for coming and stay. We have 15 students stay. And take a glance, just have an idea. I don't really like the students that they just drop by for 1 second and then leave. I'd rather you don't waste the time to do that. All right, guys. I'll see you on Wednesday. Bye-bye. Essential class, I'll see you in 10 minutes. Essential class.
Gotcha.
Yeah, I'll see you in 10 minutes. Bye-bye.